Hi students, this is Madhavrao Allah. Today I am going to discuss about the topic signal analysis in the subject signals and systems. We all know our subject is signals and systems. In that subject, one of the important topic is signal analysis. So now how the signals are analyzed. So now we have to discuss about how the signals are analyzed. So that is today's topic. Now the topic of signal analysis is a new one, especially for you. It's a complicated topic. So to understand the topic, it will take more time. It will take more time because the signal and all the signals, the topic of signals is a new one. So anywhere if you want to learn a new topic, it will take more time to understand. The same way here, for the understanding of signals, we need more time. It takes more time to understand the topic of signals and their analysis. So for that, what I have to do is I have to make the understanding easy. That will be done by explaining the concept of signals, which is new to you. So I have to explain this new topic with the help of a old topic which is already known to you. So if I explain the new topic of signals with an old topic, that is vectors, which you are already studied in your previous years. So if I explain the concept of these new signals with the old concept of vectors, then you can understand the concept of signals easily. Okay, you can understand the concept of signals easily. It will take less time to understand and it will be remembered forever if I explain the concept of these signals with the help of the concept of vectors. Okay, so is it possible to explain the concept of signals with vectors? Yes, it is possible, because there is a perfect analogy. Between signals and vectors. Whenever, if you want to learn a new thing, if that will be learned with the help of a old topic which we already know, then it will take less time and it will be easily understood and it will be remembered for more days. So for that reason, I am explaining this concept of signals with the help of vectors. If you need an example, if there are two systems, electrical system and mechanical systems. Okay, so if you know the concept regarding the electrical systems and you doesn't know the concept regarding the mechanical systems, but there is an exact comparison, there is an analogy between electrical systems and mechanical systems. So if I want to explain you the mechanical systems, I will explain the mechanical system concepts with the help of electrical systems which you already know. Then the concept of mechanical system understanding is very easy. Okay, in the same way, here also I will explain the concept of signals with the help of the concept of vectors, because there is a perfect comparison of these two, signals and vectors. So for that reason, I am going to the topic analogy between signals and vectors, or analogy between vectors and signals. So what is the analogy? So analogy, comparison. Okay, there's a perfect analogy between signals and vectors. So in your intermediate and in the previous classes, you already know a vector and how the vectors will function and what is the dot product of vectors. You will know the concept of vectors and you have a sound knowledge on the vectors. So for that reason, I am explaining here the concept of signals. That is, I am analyzing the signals with the help of the concept that we are already known, that is vectors. So I am explaining the concept of signals, or I am analyzing the signals with the help of vectors which are already known to you. Then the understanding of these signals is very easy. You don't think that it has a new topic. So if I explain the signals with the help of the vectors, then you can think that it is already known to you, and the understanding is also very easy. So I can say one thing: whenever we want to know a new thing, which is very difficult to understand, which is very new to us, if we understand that new topic with the help of old topic, if there is a comparison between old and new, the perfect comparison, if there is an analogy between old and new, if you try to understand the new topic with the help of old topic, then it is very easy to understand. Now the topic is analogy between vectors and signals. Analogy between vectors and signals. Okay. Now, first of all, we go for what is a vector, because you have to remember the old topics about vectors. First of all, can anyone tell me what is an vector? What is an vector? So there are two types, scalars and vectors. So in this class, we put more concentration on vectors. Vectors are having both magnitude and directions. These vectors are having both magnitude, and direction. Okay. Generally, these vectors are represented with boldface letters. Vectors are represented with boldface letters. Let us take V1 is a vector. V1 is a vector. We have to represent it boldface V1, or we will put a arrow mark above it. We'll put a arrow mark above it like this. So then we call it as a vector. And the magnitude of vector is represented with lowercase letters. Simply, if you want to write the magnitude of this vector V1, we can simply write as V1. So this is a representation of a vector, and this is a representation of the magnitude of the vector. Okay. So now, these vectors have both magnitude and directions. Now, what is the dot product of two vectors? Let us consider there are two vectors, V1 and V2. V1 and V2. What is the dot product of two vectors? I think you all already know the dot product of two vectors. Yes, the dot product of two vectors, V1 dot V2, is equal to the product of magnitudes. The dot product of two vectors, V1 and V2, is equal to the magnitude of the vector, that is mod V1 mod magnitude of the vectors into cos of the angle between the two vectors. Okay, so I write with the cos theta. Simply, we can write that V1 V2 cos theta. So you all know the dot product of two vectors. So these vectors concept and the dot product of two vectors will come in a few minutes. Okay, so this is regarding vectors. Now I want to represent one vector in terms of another vector. Let us take here, I take an example as V1 and V2. Now I want to represent V1 in terms of V2. How can I express V1 in terms of V2? We can express V1 in terms of V2 in infinite ways. We can express, or we can represent V1 in terms of V2 in infinite ways. Okay, so see, those are, let us take, this is a vector V2 and this is a vector V1. Now I want to represent this vector V1 in terms of V2. So that can be done in infinite ways. So in that infinite ways, I will take three ways for your example. Okay, three ways for example. Now from one end of one vector, I will draw a line onto the another vector. From one end of one vector, I will draw a line onto the another vector. That is, from one end of V1, I draw a line onto the V2. Okay, to give the component of V1 along V2. Okay, so let us consider this. As C1 V2. The component of V1 along V2. Consider this as C1 V2. And this is nothing but an error. So we can represent it as a error vector. Let us take V, E, or VE1, you can write any one. Okay, so this is the one way of representing V1 in terms of V2. So I can express the vector V1 equal to C1 V2 bar plus V1. So this is the representation of V vector V1 in terms of vector V2 simply. So this is an error vector. Okay. Now this is one way. So another way, you can go for another way also. So the another way is draw a line from one end of the vector V1 onto vector V2 like this. So this also gives some error. Here I am writing that error as VE2. That error vector as VE2. Okay. Simply by drawing line from one end of one vector onto the another vector, we can represent the first vector in terms of the second vector. Okay. So first I shown one way of this one, and this is the another way. So here also from this diagram I can write the vector V1 in terms of V2. So here I am taking the constant C1, here I am taking the constant C2. You can take anything. So here I am taking C1, there you can take C2, you can take anything. So V1 bar equal to C2 V2 bar plus VE2 bar. Okay. So in this way we can represent the vector V1, or in this way we can represent the vector V1. And the third way, so this is the best way to represent one vector in terms of another vector. So the third one is the best way. So that way is same V2 bar, V1 bar. Now draw a perpendicular line from one end of the first vector onto the second vector. So draw a perpendicular line. So here also we have the error. So I am simply writing as VE. Okay, VE, or you can write that VE12, whatever it may be, error. Okay. Now here also you get the constant. That constant I am taking as C12. The constant is C12, or you can take simply C. So the constants are for our representations, for our understanding. So you can take the constant values of your wish. So here I have taken as C12. Now from this diagram I can write the equation for the vector V1. So the vector V1 will be equal to C12 V2 bar plus VE bar. Okay. So this is the equation for representing vector V1 in terms of the vector V2. Okay. So there are so many ways. So I explained three ways. So if you can draw like this, you can draw like this. Okay, you can draw in many ways. Here see, in this tree, the best way to represent one vector in terms of another vector is this one. Why? Because in this case the error vector is very minimum, very less. It's a minimum. The error is very minimum. See, on seeing the diagram itself, you can say here this length is more. If you draw a line like this, straight line, okay, straight line. If you draw a line like this, so this is less when compared to these two. That is in this case, while drawing the perpendicular line from one end of one vector onto the other vector, gives the error value as a very less. Here in the third case, the error is minimum. In this third case. So for the third case, the error is minimum. So mathematically or geometrically, we can represent one vector in terms of another vector just by drawing a perpendicular line from one end of the first vector onto the second vector. So this is geometrically we will done, because in this case the error is minimum. So geometrically we will represent one vector in terms of another vector by drawing a perpendicular line from one end of the first vector onto the second vector. Okay, so Out of these three ways, the best suited way is this one, because in this case the error is minimum. So if you want to represent V1 in terms of V2, exactly, if this error is 0, there is no error, that means the V1 comes on to V2. If there is no error, the V1 comes on to V2. So we will perfectly represent one vector in terms of another vector when there is no error, but practically it is not possible. We have a little bit of errors. For that reason, we will make that error as small as possible. We will make that error as small as possible. That is, error should be very minimum. So by drawing a perpendicular line from one end of the first vector onto the second vector will give the minimum error. So on seeing the diagrams also, you can say in this case the error is minimum. So we will use this representation for representing one vector in terms of another vector. Okay, this is my first one. Now what is the component of V1 along V2 in this diagram? So I am rewriting the diagram again here. Okay. So this is V2 bar, this is V1 bar. I am drawing a perpendicular line. Okay. So consider this as C12 and this is VE bar. Okay. For this, the equation is this one. V1 bar equal to C12 V2 bar plus VE bar. Okay. So this is the equation. Now, what is the component of V1 along V2? Here, the component of V1 along V2, the component of V1 along V2 is given by from the diagram it will be given by C12 V2. You can say, so this is the C12 V2. So this is the component of V1 along V2. So from the diagram we can easily say that as C12 V2. Okay, so here V1 V2 are the vectors. Okay, C12 V2. Now, so we can get this component of V1 along V2 by our simple right angle triangle. So everyone knows this is the right angle triangle. Am I right? This is a right angle triangle. Let us take this as a right angle triangle. So here the angle is 90 degrees and here the angle theta. And we know the value of this side. This side is V1 bar. And the angle is theta and it is a right angle triangle. Okay. Now I need the component of V1 along V2. That means I need this one. I need this thing. How can we get that one? So in a right angle triangle, what is the formula for cos theta? So in this triangle, in this right angle triangle, what is the formula for cos theta? Can anyone say? Yeah, simply cos theta will be equal to adjacent side by hypotenuse. So here the adjacent side is component of V1 along V2. Here the adjacent side is component of V1 along V2 divided by hypotenuse. So hypotenuse is this one. That is V1 bar. Okay. So simply, if you consider only the magnitudes, we can write V1. If you consider the vectors, we can write V1 bar because the vectors are represented with a bar on this one. Now, what I need? I need a component of V1 along V2. So the component of V1 along V2 will be equal to the component of V1. That is the numerator. Cross multiplication. So I need this one. So from that, same, the component of V1 along V2 will be given as V1 cos theta. That will be given as v1 cos theta. Okay, so now this is from the diagram and this is from our right angle triangle. So both are same. Now C12 V2, okay, will be equal to V1 cos theta, will be equal to V1 cos theta. Simple. So C12 V2 will be equal to V1 cos theta. Now multiply on both sides with V2. Multiply on both sides with V2. What happens on multiplying both sides with V2? C12 V2 square equal to V1 V2 cos theta. V1 V2 cos theta. So C12 V square equal to V1 V2 cos theta. Okay, V1 V2 cos theta. Now, so in the beginning of the class, I had given the formula for dot product of two vectors. So here the two vectors are V1 and V2. The dot product of the two vectors is nothing but V1 V2 cos theta. So in place of V1 V2 cos theta, V1 V2 cos theta, I can write V1 vector a dot product V2 bar, V1 bar dot V2 bar. So in place of this V1 V2 cos theta, I can write V1 bar dot V2 bar, because the dot product of the two vectors at the beginning of the class I said V1 bar dot V2 bar will be equal to V1 V2 cos theta. So now I have the value for C12. I have the value for C12, the constant C12 will be equal to V1 bar dot V2 bar divided by V2 square. So that is the equation for C12. Here the constant C12 plays the major role. So in identifying the significance of the signals, so this C12 plays the major role. Let's take, if the value of C12 is 0, then there will be no component of vector V1 on vector V2. If the value of C12 is 0, then there will be no component of vector V1 on V2. That is, there is no possibility of drawing a line from one end of that vector onto the another vector. Okay, there is no way of drawing the line. That is, those two vectors are mutually perpendicular to each other. Then only there is no possibility of drawing a line from one end of the one vector onto the another vector. So if the two vectors are mutually perpendicular, then only we can't draw a line from one end of the vector onto the another vector. So if C12 equal to 0, there is no component of vector. There is no component of vector V1 along vector V2. That is these vectors V1 and V2 are mutually perpendicular to each other. The vectors which are mutually perpendicular to each other are called as orthogonal vectors. So whenever two vectors are mutually perpendicular to each other, those vectors are called as orthogonal vectors. Simply, orthogonal means perpendicular. Okay, perpendicular, that is 9 degrees to each other. Now, or you can say like this: for orthogonal vectors are mutually perpendicular vectors, what is the value of C12? The value of C12 will be equal to 0. That is the constant will be equal to 0. So this is completely regarding the vectors, which you are already know in the previous classes. So you all already know these concepts. Now I will use these vector concepts for explaining the analysis of signals. Now I will explain the concept of signal analysis with the help of these concepts which I explained now regarding the vectors. Okay, so now we go for the signal analysis, how the signals will be analyzed with the help of these vector concepts. Okay, I explained you that two vectors v1 v2. Okay, there are two vectors v1 bar and v2 bar. Okay, now the component of v1 along v2, the component of v1 along v2 can be given or can be represented as c1 to v2, and we can get this by drawing a perpendicular line from one end of v1 onto the v2 vector. Okay, so here if the value of c12 is 0, if the value of c12 equal to 0, there is no value of the c12, then the component of, there is no component of v1 along v2, then there is no component of v1 along v2. That is, these two vectors are like this. That is, these two vectors will be like this. That is, the two vectors, this v1 bar and v2 bar, are mutually perpendicular to each other. Are mutually perpendicular to each other. The mutually perpendicular vectors are called as orthogonal vectors. So for orthogonal vectors, the value of c12 will be equal to 0. Okay. So how can you say that? Because we can mathematically also prove this. And given the equation for c12, what is the equation for c12? So c12 will be given by the equation v1 bar dot v2 bar divided by vt square. So this is the equation for c12. Now say these two are perpendicular to each other, mutually perpendicular. Mutually perpendicular, the angle is 90 degrees. So if I expand this one, if I expand this, what I can write? v1 v2 cos theta. So here the theta value is 90. So v1 v2 cos 90 by v2 square. So I know, so all of you know the value of cos 90. So cos 90 is 0. Cos 90 is 0. So 0 into anything is 0. Anything divided, 0 divided by anything is also 0. So finally the value will be equal to 0. That is c12 equal to 0. So this is how we mathematically prove that if two vectors are mutually perpendicular, that is, if the two vectors are orthogonal, then the value of c12 will be equal to 0. So this is how we mathematically prove the concept. Okay, simply we know the c12 value as v1 bar dot v2 bar by v2 square, which is equal to v1 v2 cos 90, because here the angle between the two vectors is 90. Okay, as I said the vectors are mutually perpendicular to each other. So cos 90 is 0. 0 into anything is 0. 0 by anything is also 0. So the answer is c12 equal to 0 for mutually perpendicular vectors or orthogonal vectors. Okay. Now I am coming to the signals. How we will explain signals concept with the help of this vectors concept. So here I expressed or represented one vector in terms of another vector. In the same way, I can represent one signal in terms of another signal, with a constant like c12, So the same way how the vectors are represented, in the same way I can represent the signals also, because there is a close comparison between vectors and signals. So the way they both behave is almost same. For that reason, we are going for the analogy between vectors and signals. Here, for I take in the examples as v1 and v2 of two vectors. So in the same way, I will take x1 of t and x2 of t as two signals. Let us consider x1 of t and x2 of t as two signals, Now I want to represent x1 of t in terms of x2 of t. How can you represent x1 of t in terms of x2 of t? Can anyone tell me how can you represent x1 of t and in terms of x2 of t? Simply, so before going to that, at least you can say how we represent vector v1 in terms of vector v2. How we represent vector v1? So this is, there are some infinite ways, but the best way is drawing a perpendicular from one end of the first vector onto the second vector. So using that one, how can we represent the vector v1 in terms of vector v2? Simply like v1 bar will be equal to c12 v2 bar plus ve bar. So this is the representation of one vector in terms of another vector, or the representation of vector v1 in terms of vector v2. Using this equation, now represent signal x1 of t in terms of x2 of t. Using this equation, represent signal x1 of t in terms of x2 of t. How will you represent a signal x1 of t in terms of x2 of t? Using the above equation. Yeah, that's right. Simply, so we have to write x1 of t will be equal to some constant c12 into x2 of t. So the constant is your wish. You can take anything. Here I am taken as c12. So from textbook to textbook, they will vary the constants. So in textbook, they will take only as c. In textbook, they will take another letter. Okay. So c12, right from the beginning, I explained as c12. So here also I kept c12. c12 into x2 of t. x2 of t plus there is a error. Here we have the error vector. In the same way, there is an error signal. So we can't express one signal in terms of another signal perfectly. There is a small error, but we have to choose that error as small as possible. Okay. So that error signal can be represented as xe of t. xe of t. So by this equation, I can represent the signal x1 of t in terms of x2 of t. I can represent signal x1 of t in terms of x2 of t. So simply, so this is the representation of x1 of t in terms of x2 of t. That is x1 of t equal to c12 into x2 of t plus xe of t. xe of t. Now here the main condition is we have to choose that error should be as small as possible. For that, in vectors, we had drawn a perpendicular line from one end of the first vector onto the second vector. That will give the error will be as minimum as possible. So in the same way, here also we have to make this xe of t as small as possible. Then only the x1 of t is almost equal to xe12 into x2 of t. That is, I am representing one signal in terms of another signal. So this should be both. If x1 of t should be equal to c12 into x of t, the value of xe of t should be 0. But practically it is not 0. It has a small value. So we have to make that value as small as possible. So by this equation, if this is very small, if this is very small, how can I write that x1 of t? That x1 of t is approximately equal to c12 into x2 of t. c12 into x2 of t. So by this we can write. So x1 of t equal to c12 into x2 of t plus xe of t. So we have to make this error as small as possible. Then our signal x1 of t is approximately equal to c12 into x2 of t. So this is how we can represent approximate representation of x1 of t in terms of x2 of t. Now here we have to find out the value of c12. We have to find out the value of c12. So keep this. This is approximation. This is the exact equation. This is the exact equation. So for analysis, we have to take the exact equation. For analysis, we have to take the exact equation. So we have to take this exact equation and we have to find out the value of c12. So we have to choose c12. We have to find the value of c12 such that it has to produce the minimum value of this error. This error should be very minimum. So what is the value of c12 such that it will produce a minimum error? For that, what I have to taken? So this is a signal. This is not the value. This is a signal. So if I take the average, if I take the average of the signals, and I have to minimize the average of the signal. If I have to minimize the average of the signal, what happens? In that average, there are some positive terms. If this is signal, there are some positive terms as well as negative terms. These positive terms and negative terms will get cancelled. So if you go for the average, then it will give wrong results because in that large signal, some positive values and get negative values will get cancelled each other, and that results in a wrong values. So what we have to do to get the perfect values? To get the perfect values, what we have to do? Simply we have to go for the average of the squared error. Average of the squared error. So here the signal is xc of t. We have to go for the square of this one. So if we go for the square of this one, what happens? All the terms will become as positive. So there is no way for the cancellation of positive and negative terms. Then we can get the perfect value. So perfect minimized error value. So we have to go for the mean, that is average of the squared value. The squared value is xe square of t. Xe square of t. So for this xe square of t, I have to go for the average. I have to go for the average. That is, we have to find out average of the squared value of xe of t. We have to find out the average of the squared value of xe of t. So average is also called as mean square value. Okay. So we have to consider this one. I am representing that average value of the squared xe of t. The average of the squared value of xe of t, I am representing as like this. You can represent with any letter. So I am representing like this. Okay. So this is for the representation of average of the squared value of xe of t. Okay. Now we have to find the value of C12 such that these values should be a minimum. These should be minimum. We have to get these values should be minimum, very minimum. So the condition for that is, the condition to get the minimum value of the average of the squared xe of t. So the condition is differentiation of this constant C12. Sorry, the condition is, I am writing here. So the condition is a differentiation of this one with respect to the constant C12 and making that complete thing equal to 0. So a differentiation of this with respect to C12 and making that equal to 0 is the way to find out the value of C12 such that it will give the minimized average of the squared xe of t. So to get this as minimum as possible, what should be the value of C12? So the value of C12 for which this will be minimized, we can find out by using the equation d epsilon by d C12 and making it equal to 0. So what we have to calculate? First we have to calculate this one. And we have to make that equation to 0. That is, we have to equate the answer to 0. Then I can get the value of C12. So you have to find out the value of C1 to the constant, because the constant plays the major role. So in the vectors also, it gives the significance how the vectors are behaving. In the same way, here the value of constant C12 is very important. Based on that value only, we can describe the signals representation. Okay, so how the signals will vary, everything. So this C12 will play a major role. So here we have to find out the value of C12 for minimized average of the squared value x of t. For that, the condition is definition of these with respect to the constant C12 and making that equal to 0. So first thing, you have to know this value. How will you know this value? So first, the value is nothing but, this is nothing but average of the squared xe of t. First we have to take the square of xe of t. Xe square of t. And you have to take the average. So for average, I have to consider these signals are in the limits t1 and t2. Let us consider the signals x1 of t and x2 of t are in the limits t1 and t2. That is, x1 of t and x2 of t are in the limits t1 less than t less than t2. So they are in between the limits t1 and t2. So apply the limits. Because how will you calculate the average? If you want to average of 3 numbers, 5, 10, 15, what you will do? You will add 5 plus 10 plus 15. That will be divided by 3. So the count on the numerator. So we have 3 numbers, 5, 10, 15. So first I will add all those things and I will write the count in the denominator. In the same way, I have to get the average of the squared xe of t. So I am making the square and then average. First I have to add all the things in the numerator. For addition of a signal, we will use the integration, and these signals x1 of t and x2 of t are in the limits t1 to t2, are the limits t1 to t2. So integral t1 to t2 x square of t dt. So that is the numerator part. I added everything, and in the denominator I need the count, that is the period. So here the period is, the upper value is t2 and the lower value is t1. So here the period is t2 minus t1, that is, it should be divided by t2 minus t1. So finally, how can you write? So you can write the value of this one. Value of this one will be equal to, this will be equal to 1 by t2 minus t1 integral t1 to t2 x e square of t dt. So this is the equation for this one. Now what I have to do? I have to go for the differentiation of this one. With respect to C12. So I have to go for differentiation of this one with respect to C12. Okay, and make that equal to 0. Okay. Now anyone tell me what is the equation for xe of t? What is the equation for xe of t? Anyone tell me what is the equation for xe of t? So error signal. So what is the equation for error signal? Anyone? Simple. Here is the equation. See this equation. From this equation I can find out the error signal. From this equation, what is the value of error signal? Xe of t. From the basic equation I can write the value of error signal. Xe of t equal to, what happens? This comes this side. So x1 of t minus c12 x2 of t. So this is the value of error signal. So error signal xe of t equal to x1 of t minus c12 x2 of t. So this is the value of error signal. Now substitute this value here. And make a square of that one and calculate, apply the limits, everything, and differentiate that with respect to C12 and make that equal to 0. Do this. This is for your practice. I had given the value of xe of t and I have given the value of this average of the squared xe of t. So everything I had given. What you have to do? We have to go for the differentiation of this one with respect to C12 and make it equal to 0. So why we are doing this? To find the value of C12. Why we are finding the value of C12 constant? Because that plays a major role in representing the signals. So the significance of the signals will be explained by the value of C12. So how the signals are, whether the signals are orthogonal, that is whether the signals are perpendicular to each other or not. So everything will be explained by the value of C12. So for that reason, here I am finding the value of C12. So you all have to find out the value of C12. So this is for your practice. So find the value of C12. I will give the answer for you to check. So here, can anyone guess what will be the value of C12? So in vectors, what is the value of C12? In vectors, the value of C12 is v1 bar dot v2 bar by v2 square. So here these are the two vectors. So in place of vectors, I have taken two signals. So here the dot product of the two vectors will be analogous to signals like this. Integral t1 to t2 x1 of t into x2 of t dt. So this is for the numerator part, and the denominator what we have? v2 square. So the denominator will have integral t1 to t2 x2 square of t dt. So this is the value of C12. If you calculate everything, okay, so if we differentiate the average of the squared xe of t, with respect to C12 and make it equal to 0, then finally we'll find the value of C12 like this. So this is for your practice. You have to find out the value of C12. So C12 will be equal to, so I write this equation by using the equation what we got for the vectors. So if we calculate, we'll get this one. Integral t1 to t2 x1 of t x2 of t dt by integral t1 to t2 x2 square of t dt. Okay, so this is the value of c12. So based on that value, we can go for the analysis of the signals. So first you calculate this one, and then I will explain the topics later. Okay, first, so this is regarding analogy between signals and vectors. Simply, first a brief summary of today's class. So here what I explained, simply I explained here. First one, what I explained, how here the concept of signals is very new. For that reason, I am explaining the concept of signals with the help of a known topic, that is vectors. So for that reason, I went for vectors. Okay, what is in vector and what is the dot product of the vector, everything regarding the vectors, and how can you represent one vector in terms of another vectors, and the different ways, the different methods of representation. Okay, and I gone for the best suited method. Okay, after that I gone for the component of one vector along the another vector, component of one vector along the another vector. So that is the second one. Okay, and then I gone for value of finding the constant c12, because c12 plays a major role. Based on the value of c12, we can say whether the two vectors are perpendicular to each other or not, they are mutually orthogonal or not. So for that reason, I had find out the value of c12. Okay, c12. Now after this, I used this concept for the analysis of signals. So in the same way how I explained for the vectors, in the same way I had taken two signals and I explained the signals representation. That is how one signal will be represented in terms of another signal. One signal will be represented in terms of another signal, and what is the value of error signal, and we have to make that value as small as possible. For that reason, what will be the value of c12? I explained everything. Okay, so at the last I had given you a work to find out the value of c12. This is what we discussed in today's class. I hope you are all well understood the concepts of vectors and signals. I think this concept of signals is easy now to you. Okay, thank you one and all.